So let's check how we're going to apply the principles that we introduced in the first video to do some calculations. So in this question, they said two identical insulated spheres X and Y suspended by a thread from a ceiling are held at a small distance apart as shown in the diagram below. Okay, so this is X and there is Y. X is positive and Y is negative. So now sphere X carries a charge of 4 multiplied by 10 to the power negative 18 coulombs. It means now this is the charge for X. We can name it Q1. But are we given any charge for Y? Let's check what are we given for Y. For Y, we have an excess number of electrons, which is 30 electrons. So they actually did not give us Q2. They only gave us the number of electrons for the second sphere. So let's check the question. It says calculate the magnitude of the charge on sphere 2. So they want us to calculate the charge on sphere 2. On sphere Y. So sphere Y has excess electrons of 30. So the moment they mention electrons, you go to the principle that mentions electrons, okay? So which principle mentions electrons? That is quantization of charge. Quantization of charge, we have Q equals to NQE. That is when they want the charge. But if they wanted electrons, you're going to say N equals to Q over QE. But in this case, they want the charge. So we're going to take the first formula, which says Q equals to NQE. Q is our charge and N is our number of electrons, which is 30. Our QE is always given for us in the formula sheet, and it's negative 1,6 multiplied by 10 to the power negative 19. Then check our answer in the calculator. So this is 10.1. So let's use the calculator and see what do we get. So the answer is negative 4,8 multiplied by 10 to the power negative 18 coulombs. That is the charge for sphere Y. You can name it Q2. We are naming it Q2 because we said for X it's Q1, okay? So now the second point says the spheres are now released and they move towards each other. So they move towards each other. They say give a reason why X and Y are moving towards each other. That is very simple. That's because X is positive and the other one is negative. Therefore, unlike charges attract each other. Everyone knows that, right? Then the spheres are allowed to touch and then they move away. That means they're separated. So they move away from each other. They're separated. So the moment we talk about touching and separation, we go to principle of conservation of charge. The two spheres, they're gonna touch, then they move away. They share the charge equally. Now they each have a new charge. So now they say state the principle of conservation of charge. They actually gave you a clue here by saying state the principle, because they're telling you you're going to use that principle to calculate the new charge, okay? So 10.4 says calculate the new charge. So we're going to use conservation of charge, which is this formula, Q1 plus Q2. So Q naught, which is the new charge, will be Q1 plus Q2 over 2. Q1 we said is for X, which is 4 multiplied by 10 to the power negative 18 coulombs, plus Q2, which is negative 4,8 by 10 to the power negative 18 coulombs. That is Q2. We said this is Q2. And then we divide everything by 2. Let's see what we get in the calculator. I get 5 multiplied by 10 to the power negative 7 coulombs. That is the net charge for each one of them. So each one is going to get the same equal amount of charge, which is 5 multiplied by 10 to the power negative 7.